Hello, May class, and welcome to your next lesson. You may be a little bit confused by the date, but we previously were going to use these on Friday, and obviously they've got Friday's date, but we're actually going to be using these today on a Monday. So you are in the correct lesson. It is your Monday lesson. So please just ignore the date that is written at the top of our page. Hello, May class, and welcome to your final maths lesson for the week. We have obviously been looking at equivalent fractions this week and finding equivalent fractions, and I have discussed with you different ways that we can do that. So let me share my screen with you. And we will start off with the arithmetic. So please make sure you have a piece of paper and a pencil, numbers 1 to 10, and then complete these questions that have been given to you, and then I will go through the answers with you. So pause the video now and answer these questions. Right, so we're going to go through some of our answers now. And I will just read down the page. So 3 times 3 is 9. 1,345 plus 3,333 is 4,678. What is today's date as a Roman numeral? So if we have to break it up, we've obviously got a 5, a 2, and a 2021. So 5 is V, 2 is II, and then the 2000 would be MM. 21, we've got XXI. What number is next in the sequence? We've got 45, 41, 37, 33. It is descending by 4. So if the difference is 4 between each number, so the next one down would be 29. 9 times 7 is 63. 64 divided by 4 is 16. What is, sorry, 500 millimeters in centimeters? It is 50 centimeters. There are 10 millimeters in 1 centimeter. So in 50 centimeters, we have 500 millimeters. We have discussed the meters and kilometers, about there being 1,000 meters in a kilometer. So 3,000 meters will have 3 kilometers. What is 20 past 9 p.m. on a 24-hour clock? The answer is 21:20, and then 54 divided by 6 is 9. So pause the video now if you need to check some of your answers, and give yourself a tick if you got it correct, and just a dot if you have it incorrect. Right, so today we're going to be explaining fractions that are greater than 1. And I have briefly started discussing this with you, and 1 or 2 of you, I posed this question when I put the extension question under your tapestry of how do we know that a number is, well, how do we know this? So we're going to have a better look at it. So just to start off, I want you to use these digit cards to make groups of fractions that are equivalent. So how many equivalent fractions can you find? So pause the video now and see if you can make some equivalent fractions using these number cards. Right, so underneath, I have written some of these, and you can see that I've made equivalent fractions. So I've used 1 over 2 is a half, is the same as 2 over 4, which is a half, which is the same as 3 over 6, because that is a half. And I've also said 6 over 12, and those also equal half. So see if you got any different ones. Right, so today we're going to be looking at what happens when a fraction is greater than a whole. And in the previous lesson, I explained, and I have said this more than once, that if we were looking at a fraction, for example, we have this, and we have, let's say it's in thirds, or let's have it actually in quarters. Okay, your quarters would be each one of these. These are obviously your quarters. So that is a quarter, that is a quarter, that is a quarter. and that is a quarter. And then I discussed with you how 4/4, so all 4 pieces, equals 1 whole. So this whole shape is equal to 1 whole. So all the pieces together, because the fractions are part of a whole, and I'll write that here. Fractions are part of a whole. So I want you to have a look at this question here. We have got 2 bars. We can see this one, 1, 2, 3, 4. So it's 4/4. And this one is showing me 1, 2, 3. So that is showing me 3/4. So if I put them here, we have 4/4 and we have 3/4. And it says that this equals 7/4. We can see that that actually, oh, sorry, that shouldn't be a, that should be a plus. So 4/4 plus 3/4 gives me 7/4, because I've got 2 shapes that are broken into 4 equal pieces, okay, of which 7 of them are colored in. I can see, just as I've discussed here, that this shape here is equal to 1. So if I have all 4 pieces, it is equal to 1. But then I'm left with 3 separate pieces that obviously are not part of the 1. They are here. So there's 1, 2, 3. And those are not a whole, because this one here is not colored in. That one there is not colored in. So that is 3 parts of a whole. So what we have is 4/4, which is equal to a whole, and 3/4, which is not equal to a whole. But what you can see is that we have more than 1 whole here. We have 3/4 more than 1 whole. So if we look, we have 7 quarters in the diagram, because there are 7 parts of 4 of each drawing that are colored in. So 1, 2, 3, 4, 5, 6, 7. There are 7 quarters in the diagram. We know from what I've discussed with you that 4 quarters makes 1 whole. So 7 quarters is going to be 1 whole, because it is this one here, and then this one here of 3 quarters. So just take a pause and read this again. There are 7 quarters in this diagram. 4 quarters makes a whole, so 7 quarters will be 1 whole and 3 quarters. I want you to have a look at this one and think, how would you split up this fraction so it became wholes and a part of a whole? So the starting point for this is the following. Look at how many parts make up a whole. And I can see that I've got 1, 2, 3, 4, 5. 5 parts make up my whole. So I know that my whole will be over 5. Okay, so let's count how many blocks are colored in. So we've got 5 there, 6, 7, 8, 9, 10, 11, 12, 13. We have 13/5 here. This should be 13/5. If we break this up into bits that are completely wholes and bits that are not completely colored in, we will have the following. Just draw it for you. We'll have 2 parts of one there and one here, because I'm going to break this up into 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And in that, I'm going to color them in a different color. You can see that actually this bit here is colored in. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Okay. You may be saying, why don't we just make it out of 10 or out of 15? Well, the reason we don't do that is because it is showing us that is one whole. That is one whole. They are not joined together. So I know that my shape is it's over 5. It's one whole is made up of 5 pieces that are cut. Well, one whole was made up into 5 equal pieces. So this I can even say is going to be 10 over 5 and 3 over 5, because 10 are colored in and 3 are colored in there. Again, I've already said to you that 5 over 5 is equal to one whole. So 10 over 5 is actually made up of 5 over 5 plus 5 over 5, which tells you that it is one whole, 2 wholes. So actually 10 over 5 is the same as 2 wholes. And then we've still got 3 over 5. So when we split this fraction up, if the numerator is bigger, we know that we have more than one whole. Okay, so when we have 10 over 5, I know that 5 goes into that equally twice. So I know that it's made up of 2 wholes, and then I have 3 fifths left. Okay. So I want you to have a turn at doing these 2 questions. Okay. Think about what we've just discussed in the previous one, and then I will go through it with you. It says complete a part-whole diagram to answer these questions. What are 9 fifths the same as? How many quarters are the same as 2 wholes and 1 quarter? So the first one you're going to do is obviously 9 fifths, and I'm just going to help you with a starting point, is that you know that if it's 9 fifths, okay, remember that 5 over 5 is equal to 1 whole. Okay, so pause the video now and complete these 2 questions. Okay, so let's go through this together. It said that 9 fifths is the same as what? So I know that 5 over 5 is going to give me 1 whole. And actually, I can see that because this is one whole, which means that I'm left with 1, 2, 3, 4 fifths. So it'll be 1 whole and 4 fifths. So 9 fifths is the same as 1 whole, or 5 over 5 and 4 fifths. When we are looking at this one, they've already broken it up. They said how many quarters are the same as 2 wholes. I'm going to put 2 wholes down here and 1 quarter. So that's what that question is saying. You remember what I said about the question. So we know that quarters are like this. So 4 over 4 is equal to 1 whole. And this is showing you 4 over 4 and 4 over 4, which makes it 2 wholes. And this is showing you it is not complete. It's only showing you 1 quarter. So how many quarters are made up of 2 wholes and a quarter? You've got 1 here, you've got 4 here, and you've got 4 here. So in total, there are going to be 9 quarters are equal to 2 wholes, and 1 quarter. Okay. Right, I want you to draw this part whole model and write sentences to describe what the fraction 14/6 is equivalent to. So what is it equal to? So pause the video now and work that out. Right, giving you some time to do it, so let's talk through it together. Again, we are breaking this up. We know that 6/6 is equal to a whole. Okay, so 14/6. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It actually should be 8/6. This should be 8. 8/6, not 14. So if we have 8/6, we've got 6/6 here, and we have got 2/6 here, which then means we've got 1 whole, and we have 2/6. Okay, and it says, can you find something that it's equivalent to? We could find an equivalent fraction to this. It makes no difference if the numerator and the denominator are top heavy, because like I said with my working out, we could find a equivalent fraction by multiplying both top and bottom by something. So we could do times, well, let's actually do it like this. We could do divided by 2, because 6 can divide into that, so it would be over 3. It would be 4/3 because we divide that by 2, which would be the same as 1 1/3. And this is obviously 1 2/6. So actually 1 2/6 is equal to 1 1/3, or if you want to keep it how it was, 8/6 is equal to 4/3. Okay, because it does work. You can divide the numbers by both by the same amount. Right, let's have a look at this question. It says, Jessica says, it is important for me to have more than 4 quarters of pizza, as a quarter is a pizza split into 4. Do you agree with her? So do you think, yes, I agree with her, or no, I don't? And I want you to sketch a picture to help with this. And I will put something in there for us. So let's have a look. Get a pen. She says, it is impossible for me to have more than 4 quarters of a pizza, as a quarter is a pizza split into 4. So if this is our pizza and it has been split into 4, Jessica says it is impossible for me to have more than 4 quarters of a pizza, as a quarter is a pizza split into 4. Do you agree? So give it a thought. She says 1 quarter is split into 4. So 2 quarters she could have, 3 quarters she could have, 4 quarters she could have. So is it impossible for her to have more than 4 quarters of a pizza? If she has 1 pizza, maybe. But if she has 2 pizzas, both split into quarters, she can still have more than 4 quarters, because she'd have another second pizza. So this is obviously 4/4. But if she had this one and this one, we could see that she could have had 6 quarters, which is more than 1 pizza. So actually, she can have more than 4 quarters. It would just be another whole pizza. Right, your independent work today is as follows. You need to complete these sentences. It says, there are 7 fifths together. 7 fifths is how many wholes and how many fifths? Question 2, shade the bar model to represent the fraction 5/3. 5/3 is equal to how many wholes plus how many thirds? And then you can give me a mixed number. Question 3 says, complete this statement. 12 halves is the same as how many wholes? 15 quarters is the same as how many wholes and how many quarters? 12 quarters is equal to how many wholes? And 15 halves is equal to how many wholes and how many halves? Then Whitney bakes 26 muffins. Muffins are packed into boxes of 4. How many boxes can Whitney fill? So you need to work out how many boxes she can fill. Don't forget to share your answers with us on Tapestry. Please make sure to write down any questions that you may have about your maths, and we will try our best to answer them during the live lessons. Please make sure, especially when you're drawing your fractions, to use your ruler and to lay your work out neatly. It is very difficult for me to read your work if it hasn't been laid out neatly and it hasn't been numbered, just like you would number it at school. So please make sure to do that.